And welcome back to the Congo channel. And in this video I'll be discussing the SN1 reaction. I decided I'm going to make some mini video series to discuss some of these mechanisms to help you prepare for your exam. It's not going to be super detailed, but I hope it helps. So the SN1 reaction versus the SN2 reaction. So big picture here. One of them is going to happen in 2 steps. One of them is going to happen in 1 step. So your nucleophile strength is going to vary. You're going to have a weak nucleophile for your SN1 and strong nucleophile for your SN2. The first step that happens in the SN1 reaction, also known as the slow step as labeled here, is your leaving group is going to leave. For something to be a good leaving group, it has to be a weak base. So let me ask you a question. I'm going to pause myself so you can answer it. If I had an OH atom here instead of a L, pretending that L is like a bromine atom, because the bromide ion is not a strong base, would the hydroxyl group be able to leave? Would it be a good leaving group? And the answer to that should be no, because you're going to form a hydroxide ion. Remember, sodium hydroxide is a strong base. And so basically, after having the leaving group leave, you're going to have a carbocation intermediate. And a carbocation is going to be flat. So what does that tell you about its geometry? So I'm going to pause again, and hopefully you can answer the question. Is it going to be Sp, Sp2, or Sp3 hybridized? So the answer is Sp2 hybridized. It's going to be flat, meaning that the nucleophile can attack from the top or the bottom. So the reason why you have a weak nucleophile in an SN1 reaction is because you have a carbocation atom. The carbocation has a plus charge, has the charge on it, obviously, and carbon likes to form 4 bonds. So that's going to allow for even the weakest nucleophile to attack, because to basically stabilize that carbon atom. And so the best carbocation, if you were to ask yourself, rank them, you're going to want the more substitution. So 2 is better than 1. Obviously 1 is very, very reactive. I don't even know if it forms very often, but there's always exceptions to it. But 2 will be better than 1, and obviously 3 would be better than 2, right? And the reason why 3 is better than 2 is because you're going to have these, let's say, carbon atoms. If I were to put a methyl group and a methyl group there, those are going to be known as electron donors. So that basically, electron donors are basically, so you know an electron has a negative charge, right? Like a proton has a plus and then an electron has a negative. That's going to donate the electrons to that carbon atom basically to stabilize it. If you think of it as a hot potato, think of the carbon atoms acting like a ice or whatever. I don't know. Whatever you're putting them in the fridge. I don't know. Something to cool out that carbocation, and that's what stabilizes it. But it's still unstable, so something like even water in solution can come and attack it. Now, when the water attacks it, you form an oxygen with 3 bonds, and oxygen likes to form 2 bonds, so the oxygen atom gets a plus charge. And what would happen afterwards is you'll have another water in solution that will deprotonate that, and then you'll end up with your hydroxyl group forming on the carbon atoms. And depending on which products you're forming or you're discussing here, you can say that it retained its configuration or it had some kind of inversion. So if it was R and became S, that's inversion, and if it's R and it became R, then it's retention. And if we form 50-50, we call that a racemic mixture. So if you have 50% of R and 50% of S, those are basically what they call optically inactive. That means that they cannot rotate plane polarized light. So if you put them in a polarimeter or whatever they call it, they're going to cancel out basically. So you have 50 going this way and 50 going that way, and they cancel out. Thank you for listening. If you have any questions, suggestions, or would like me to cover any other topics briefly and get to the point, please let me know. And look forward to making more videos.